And welcome everybody to the Smash News Network, least busted name in news, just bringing you the world's most comprehensive daily space weather show. Exciting times continue for space weather. At least one more coronal mass ejection on the way. And we're looking at ionized carbon here to start out the video. 1600 angstroms depicts ionized carbon, and what this is really good for is showing us where the most active regions are. So you'll see a bunch of white happening there. The white is basically the carbon graph being maxed out. So there's a lot of carbon where you see the color white, and then down to that yellowish color, and then of course you've got the sunspot regions there shown in black. So 1600 angstroms is good at showing sunspots and where the activity is crackling. So you'll be able to see that on that imagery there. That's 30 frames per second from SDO. It's a 24-hour video from today, the 20th April 2024. Now we do have some new active regions, some new legit sunspots here rising and forming in the east. So you'll see some of those areas brightening up. That's part of the reason why we included it in this beginning portion of the video. And we're going to come back to more spectacular custom solar imagery for you here in a moment. However, before we do that, let's take a look at, there is a SDO browse data feature. And look, you see the sun vibrating there. It has to do with the synchronization of the different wavelengths. That's not really happening. And yeah, if you're spooked that the galaxy is going to make the sun vibrate or something, then I don't know what to tell you. It's the galaxy, like the sun, not scary. Not scary. So anyway, that's just from today, once again, April 20th, 2024. That's showing 3 different wavelengths. And we do have a very high likelihood of X-class solar flares. Let's briefly take a look at what's going on planet Earth. The erupting volcanoes include Tal, which has produced some phreatic explosions. Phreatic eruptions are caused when lava or magma interact with water. That causes steam to rapidly form, which can be explosive. Ibu also exploding. Semeru, intermittent emissions of volcanic ash. Merapi, unknown volcanic ash plume there. Dakono, producing a 9,000-foot plume of volcanic ash. Ruang, on the Isles of Sulawesi and Sangihe. 5,000-foot ash plume there from Ruang as it explodes. Santiaguito down in Guatemala also exploding. Fuego, Sangay, and Sabancaya. The world's largest ash plume coming out of Peru at 24,000 feet of altitude. Please do not pole vault the caldera. Of all the track and field events you could participate in, don't include volcanic caldera pole vaulting. That could be unhealthful. So we've included this public service message at massive personal risk and expense for your viewing pleasure. Next, volcanoes. We just did that. So here are earthquakes. That's the past 90 days of earthquake activity. And yeah, it's been pretty chill over the past 24 hours. Not a lot of big quakes, not a lot of quakes, period, but quite a few around the Pacific Rim there, just no large ones. So Saipan had a 5.0 at nearly 500 kilometers estimated depth. I think that might be the only 5 or greater magnitude quake for the past 24 hours, and indeed it is. So there you go, only one quake of a 5 and greater magnitude. And how about some more solar imagery? So there's our 304 angstroms, the classic ionized helium wavelength. More 24-hour videos from Solar Dynamics Observatory at 30 frames per second. And here's a close-up of a series of sunspots. That's like 4 or 5 named sunspot groups, actually. And we see the possibility of chromospheric heating going on there. It's where you see that solid, nearly solid orange color. That is not all that normal. another super interesting sunspot that we get the awesome opportunity to not only view, but show our viewers. So here's our house favorite wavelength, 171 angstroms. And let's move on to some more stats. The 10.7 centimeter radio flux has now dipped. It's now down to 210? 210, I think it is. Yeah, solar flux units are now down to 210. 210 solar flux units is the 10.7 centimeter radio flux. It comes out of the upper chromosphere and lower corona, so we made that convenient animation for you there, showing a radio tower, because radio frequency, it's a radio signal, part of the electromagnetic spectrum. So yeah, there's the 1 year graph, and check it out. Sunspot number made it all the way up to 247. 247. So that was a new high in sunspot number. So if there were any channels out there who are talking utter nonsense and telling you that we were at solar maximum in January and February of 2023, please show them this graph. And I don't know what their viewers are looking at. I don't know how their viewers accept this content as factual, but there are lots of people spouting nonsense about space weather and clearly having no grasp of physics at all. But anyway, here's our space weather enthusiast dashboard, and things are pretty chill. Although we and DSA are expecting another coronal mass ejection impact sometime late in the day on the 22nd. So it doesn't look like NOAA's forecasting that, or they think it's moving more slowly. So as you can see there, no impact shown by NOAA, but the European Space Agency begs to differ. So it's going to be a minor impact. There you can see it's, again, late in the day on the 22nd into early in the day on the 23rd. And it is basically a glancing blow that will mostly miss Earth to the east. As you can see in ESA's Enlil spiral, there's their new data portal. It's just fantastic. Here are the past 4 hours of Earth's magnetic moment from space as modeled by the Space Weather Modeling Framework. And things have returned to geomagnetically calm conditions. Now, I was dead wrong yesterday. I said the KP5 would subside, and instead we ended up with a KP7. But it was only for a very brief period of time, less than 3 hours. So those are the past 4 hours of Earth's magnetic moment from space there, and things are chill. It's geomagnetically calm at the moment. Earth's magnetic moment from the ground agrees. Geospace delta B would be changes to the field going through the magnet, this magnet being Earth. If you've got any imagery of aurora that you found yesterday or that you took yourself, definitely share that with us. KP index now at 2. KP2 is the geomagnetically calm situation for global geomagnetism estimates. As far as solar wind, it is pretty nominal. That's the readings from ACE right there, ACE orbiting Lagrangian point 1. About 450 kilometers a second and less than 1 proton per cubic centimeter. Discover also orbiting Lagrangian point 1, showing a much denser wind there at a little lower speed, 468 kilometers a second, or a little higher speed, 468 kilometers a second, and about 7 3/4 protons per cubic centimeter. So yeah, calm conditions, and you'll see some big variations there in the GOES magnetometers. That is the arrival of last night's coronal mass ejection impact. And again, there's at least one more on the way. It'll be a minor glancing blow, sort of a brush past sort of an impact, if it's an impact at all. We won't expect to see any geomagnetic storms, maybe a little bit of geomagnetic unrest, but probably nothing more than like a KP 3.6 or something like that. So they're the past 3 days from the GOES 16 and GOES 18 magnetometers. And as we forecasted yesterday, Earth is now in a North Pole-oriented magnetic sector, and we've got coronal hole features rotating in here that are also of North Pole orientation. So don't mispolarize your coronal holes. Make sure you watch our channel because we provide all kinds of facts. There's our line of sight field plot and lots of magnetic complexity on the Earth side of the solar disk, having just reached 247 sunspots yesterday. So check it out, some gaping coronal holes here showing up as well. South pole oriented ones up at the north heliographic pole, and then we've got North Pole oriented coronal holes rotating in here around the equator. So those are expected to become geo-effective in, I'll say, about 5 or 6 days. That's the past 4 days. That's our line of sight coronal hole plot. And let's move on to, there we go, coronal holes from the SDO. So 211 angstroms is fantastic at showing coronal holes. And you can see that one that is indeed a trans-equatorial coronal hole. Of course, Earth always orbits near to the sun's equator. So trans-equatorial coronal holes are the ones that are most likely to cause a high-speed solar wind to show up all the way over here, 93 million miles away at planet Earth. So them's the facts, and let's move on to sunspots. Sunspot number now has dipped a little bit to, let's see, what do you got? 222 is the Royal Observatory of Belgium's sunspot number. 222. And by the way, if you enjoy the content, don't forget to press the like button. Press the share button after you leave a comment. If you're new to the channel, press subscribe unless you don't want the world's most comprehensive daily space weather content delivered directly to your YouTube feed. If you don't press like and subscribe, well, that's on you. Accept no substitutes for the Daily Space Weather Show. There is absolutely no competition. And we do market research. I defy you to find competition for this channel. They are comedians, not space weather forecasters. Anyway, look at the high likelihood of X-class solar flares there out of that sunspot in the south central region. Sunspot 3638 is the one that it's highlighting there as 61% likely to produce an X-class solar flare, even more likely than an M-class solar flare, according to that. And also there's an area in the northern hemisphere, that's sunspot 3639. So yeah, very high likelihood of major solar flares, and the likelihood of proton events is now rising as well. We may see some solar energetic particle events, extended periods of polar radio blackout, and of course equatorial radio blackout from the flare itself arriving at planet Earth. Now a lot of people, they say, when's the flare gonna arrive? And the answer is, first of all, the X-rays never make it to the ground. So from a terrestrial perspective, the flare's never going to arrive because it's filtered out. It's absorbed by the atmosphere by the time it reaches the stratosphere level, I think, and or it's adsorbed by the time it reaches the bottom of the mesosphere. And yeah, so flares never reach Earth, and it sounds like when somebody says that, when's the flare going to arrive, what they mean is, when is the coronal mass ejection going to arrive? A completely different phenomenon. Coronal mass ejections are protons. Solar flares are X-ray photons. Very different. Very different. So, anyway, sunspots from SDO are next. And here is our SDO magnetogram. And things are pretty stable there in the central part of the disk. We do have a little bit of growth in the eastern part. So it looks like we'll have an increase in sunspot number. Of course, I said that yesterday too, and we had some degrading groups between now and when yesterday's video got produced. So we saw a little decrease in sunspot number. Now we're expecting once again a little increase in sunspot number because we have some new unnamed groups that have both risen and formed in the east. So here you'll see that a little bit. We didn't worry about it too much and like zoom way in and like get all in depth into it. But yeah, so I see at least 2, probably 3 more named groups there forming in the east. Yeah, it looks like an uptick in sunspot number there. Now, that is a 24-hour video, so again, just like with yesterday, things can change rapidly. So, but at the moment, if the trends that we're currently seeing continue, then we can expect to see a modest increase in sunspot number by tomorrow's daily space weather video. Next, we'll move to solar energetic particles and flares. So no spikes in the proton flux. Like I said, the likelihood of that is rising as major sunspots move toward the western limb. And the X-ray flux, no M-class flares over the past 24 hours. The flaring has been quiet. Is it the calm before the major radiation storm? Well, it's pretty likely, considering the magnetic complexity of the sunspots that we're seeing on the Earth side of the disk. Let's take a look at, how about a little bit of 94 angstroms from SDO. So our T mass is that entire group of sunspots there that's just moving to the west of the center disk. So just in the past 24 hours there, moving into western longitudes, those southern sunspot groups have been by far the most active. We are seeing some activity rising there over the eastern limb as well. So it looks like another significant sunspot's about to rise there, as we have seen some flares already coming from behind that southeastern limb. So that's pretty cool. And let's move on to CMEs. But first, a star chart. So there is our solar system layout for today. That's where things will be in 1 week on the 27th. And next, a star chart. That's what's going on overhead at 40 degrees and 34 minutes north longitude and 75 degrees and 35 minutes west latitude, 40 degrees and 34 minutes, and longitude is 70. Well, anyway, it's on the screen. I'm not used to reading coordinates. Yeah, so if you're up early in the morning, you may see Venus and Mercury rising behind Mars and Saturn. So Venus and Mercury quite high in the sky for them right now. Venus actually lower than Mercury. So 4 planets there in the early morning sky if you want to check that out. Next, our astronomy photo of the day. Pretty sweet. We've got both diamond rings taken from northern Arkansas during the April 8th eclipse. There's your diamond ring in the upper left, the pre-totality diamond ring. And then you've got the totality there. Great resolution of the solar corona. Nice job, Wright Dobbs. And then the end of totality diamond ring phenomenon as well. The sun emerging from behind the lunar disk, which probably made ancient people calm down, as that would be pretty freaky if you didn't know what was going on. Especially if you're a farmer, right? So yeah, apod.nasa.gov if you'd like to check out those images yourself. Next, CMEs, and it's been calm for the past 24 hours. We won't spend a lot of time on it because why? It's been chill. So there's LASCO C2 and C3, and again, nothing particularly interesting here to report on. We'll show stereo A. I just froze those frames. Let's switch to our custom coronagraphs. So interestingly enough, there actually is another Earth-directed component. So another CME to arrive on the 23rd, and it's this one that's mostly coming out of the south here. You'll see right in this area, you'll see a filament eruption right there, and then you see a CME following it. That's going to have earthly directed components. So now 2 more CMEs on the way. Oh, and these videos come from HelioViewer, by the way. Yeah, so now 2 more CMEs headed in Earth's direction I love it. It's fantastic. It's good times for space weather. So here is our Cerdatololo ground-based hydrogen alpha telescope. You can see some prominences there rising in the southeast. That's being suspended by the magnetic fields of some yet-to-rise sunspots. And lots of absorption features there showing up as dark areas. Those are Earth-facing solar filaments. So look at the number of filaments here. The likelihood of additional coronal mass ejections for the next 24 hours is just this side of 100%. So lots of filaments, and some really dense, massive ones over here on the east especially. But just lots of filaments. I mean, look at the last image. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's like 15 filaments on the Earth side of the disk. Before we get to bonus features, let's look at the last couple of hours here from the GO 16 SUVI for sake of completeness. And there is more ejecta blasting off. Depending on how that shows up on the coronagraph, that could be another CME impact. The 22nd and 23rd could be some interesting days for space weather. Moving on to bonus features. Satellite charging hazards, we've got some minor ones there over the northern Indian Ocean, Southeast Asia, and the Middle East. GOES electron flux here coming up off the floor, at least for the GOES 18's radiographic measurements. Those satellites are located at geosynchronous orbits that are at like 23,500 miles of altitude. So they use radiography to look down at the Earth. They're endeavoring to measure the electron flux at the F layer of the ionosphere using their radiographic measurements. It's almost like radar. So yeah, there's the GOES 18 coming up off the floor, and we can expect a rise in electron flux. Let's see if NOAA agrees. That's the past 1 year of electron flux, and it looks like NOAA does agree. We called that one yesterday, and it looks like NOAA changed their forecast. Dear NOAA, if you're viewing the videos, please share our videos on your social media accounts. It would be extremely helpful if you, NOAA, the National Oceanic and Atmospheric Administration, would share the content, especially if you're viewing it and using it for your forecasts. That would be a smart move. Here's the layer where it's measured, the ionosphere. And folks, knowing how the variables tie together is the key to forecasting. If you know how the cold air and the dry air and the wet air and the cold air and the hot air and the wet air and the dry air and so forth, if you know the way those things interact with each other, you can forecast Earth weather. Same thing with space weather. Anyway, here's the ionosphere, and you'll see a lot of low-frequency anomaly here. We did reach KP7 yesterday, so that caused significant scintillation of the ionosphere, causing it to both puff up and puff down. The whole thing expands and gets bigger. And that shows up as low-frequency anomaly on the ionogram, or the ionosonde, as it's called. So if that's all Greek to you, don't worry, we'll show the anomalygram as well. So if you're new to the channel and you have no idea what you're looking at, well, there it is. That shows low-frequency anomaly in red, high-frequency anomaly in blue, and the anomaly is based on the 30-day median. So yeah, lots of red showing up there, and since then, long ago, the geomagnetic storm conditions have subsided, and you will see the ionosphere following suit shortly. So here's the Global Ionosphere Nowcast, or WAM, the whole atmosphere model. And we've got some huge GPS errors once again in the southern Atlantic, the Indian Ocean, and especially the Central Pacific. Look at the total electron content anomalies there. A lot of red with high electron count anomalies. So that's your Global Ionosphere Nowcast. We'll close out space weather with the latest high-res images. Now, like I said, there are several new sunspots rising and forming over here in the east. I think as many as 4 new groups, but at least 3. So here's the continuum now that we showed you the colorized magnetogram. just to give you an idea of what's happening over there in the east. So there is 1, 2, both beta class sunspot groups. That's 3, 4, 5. That's at least 5 new sunspot groups. So if those are around for 12 hours or more, you can expect to see those get named, and 5 new sunspot groups will equate to a higher sunspot number than we have today. That'll be a lot more groups showing up, rising and forming, as opposed to one small group setting in the west, as the likelihood of solar flares remains extremely high. Let's take a brief look at the magnetic fields here. Come on, then. There we go. And there are some deltas in there. So beta gamma delta class sunspots are the kind that you want to see if you like solar flares. And let's move on to meteorology. So, thanks for tuning into the Smash News Network, least busted name in news, by the way. And if you're wondering why I say that, it's a direct insult to CNN. CNN, the corporate nonsense network. So, CNN bills themselves as the most trusted name in news, or they used to. So, we are doing some wordplay on that and calling ourselves the least busted name in news. Because we're legit, they're hucksters. You see the difference? Now, we're looking at the Duex right now. That is dust, Saharan dust, making its way across the central Atlantic Ocean there. And so that's going to make weather systems less likely to form. And it's going to fertilize the northeastern South American coast. So that'll make for some extra fertile soil. Yeah, desert sand is extremely high in nutrients. It's just bad at retaining water. That's the main reason why stuff doesn't grow there. If you find a way to retain water in your desert location, things grow epically. Lots of nutrients and lots of soil freedom for roots. So yeah, that's the scenario for dust. Some Saharan dust, quite a lot of Saharan dust making its way across the Atlantic. Here's our regularly scheduled meteorology stuff, starting with surface winds of the eastern world. Shout out to our viewers from the east side. There are your jet streams. Shout out to our viewers from the central world. There are your surface winds. Shout out to our viewers from the west. There are the jet streams for this neck of the woods. Next, satellite imagery. We show the visible satellite. Now, our regular viewers are aware that Earth is clearly croissant-shaped, not shaped like an oblate spheroid. I mean, duh. You think Earth is really shaped like an oblate spheroid? Like Neil deGrasse Tyson would tell you Earth is shaped like an oblate spheroid if it really was? I mean, come on. He's like a spokesperson for NASA. Everybody knows that about Operation Paperclip. I mean, the fact that Nazis were hired to found NASA is a clear indication that they want you to think the planet is not shaped like a croissant. I mean, what kind of psycho goes around taking a croissant-shaped image of a planet and then putting it onto a spherical template? That's just crazy. Crazy and stupid. Anyway, here's our snow depth monitor from Witty.com. And check it out. The hot air of Colorado must be closing down. Look at Colorado. I mean, how is there so much snow still there with so much hot air still coming out of the state? I don't get it. Can anybody leave us a comment and let us know what's going on in Colorado? Is there some kind of a problem with all the hot air? Because, I mean, there's definitely a lot of hot air, a lot of Bengay and patchouli scent. So I don't know. Let us know in the comments what's going on. I'm a little worried about Colorado. There may be a hot air shortage. Maybe the cult leaders have decided to move out. Maybe they're operating their cults remotely now. Lots of snow remains in Aspen and Vail. Spring skiing. Anyway, here's our weather.gov map. We'll briefly scroll down to show you the key. But what you ought to do is go visit weather.gov if your location is lit on the map, because we're too lit to show you all those counties. We've got things to do. So here's a 72-hour GFS pressure and precip forecast. Some heavy weather coming to the Gulf states, especially Texas and Louisiana. And a tiny bit of that precipitation will be in the form of snow. A tiny bit. We show 3-day forecasts on the channel because those are accurate. Now, of course, if I had to do a very specific forecast for a small area, then I would zoom in on that area and talk about how the air masses are moving around and things like that. But yeah, we keep it a little general. We bring the weather from space down to the lower 48, and we just keep it at that. If you've got a specific forecast that you want for a specific time, drop us a comment, and we will consider it. Next, a total accumulated precip. And like the snow depth, that's in inches. And like we said yesterday, Texas expecting some areas there of over 4 inches of the wet stuff. The wettest stuff there is, water. Last but not least, temperature anomaly forecast in degrees Celsius. Colder weather returning to the eastern half of the country. The Great Lakes states will get a little bit of warmth there, as well as rapid melting coming to California, Nevada, Utah, and Colorado. So some very, very high temperatures coming to those states there west of the Rockies. 72-hour GFS temperature anomaly forecast. Next, lightning, and we had a huge train of lightning here make its way across Texas into Louisiana, Arkansas, Oklahoma, Mississippi, etc. Well, there's the map. Just look at the map rather than have me try to explain it. That's just ridiculous. And here is our real-time lightning map from lightningmaps.org. And what do you got? Hey, Columbus, Georgia. Hey, LaGrange, Georgia. There's thunder rolling in. LaGrange, Georgia. Seems like an interesting point on the map. Get it? Lagrange point? That's some space weather. That's some space weather humor for you. Get it? Lagrange point? All right. So we'll close out with Doppler radar, satellite imagery, and of course, water vapor. Oh, let's zoom in on the lower 48 first. There we go. Pacific Northwest getting precip once again. There's satellite imagery, visible satellite, and there is water vapor. So here's a recap before we close this thing out. U.S. Doppler radar ground-based system, space-based system showing the visible imagery, and space-based systems showing the water vapor. And here's me signing off. In the meantime, I've been your host, Dan, a.k.a. Smash-a-Mash, and may that solar wind be at your back. Back to the bunker. S-bars don't fail me now. Whoa!